All right. Hi, everybody. Our test will be a week from Thursday, and yes, it is supposed to be the 19th. I'm so sorry. All right. We know that the tangent function is sine over cosine at this point. And so therefore, the function f of x equals the tangent of x is a rational function if you kind of think about it like that. So you can think of it as sine of x over cosine of x, but that is kind of like almost too much information at this point. So we kind of need to break down what that means. So what it means is that um, discontinuities in a rational function happen when the denominator is equal to zero. And so any place where the cosine of x is zero, that's going to be a discontinuity. And in fact, those are going to be vertical asymptotes. And so if you think about the unit circle, here's my unit circle, the cosine is zero right here and right here. And so those spots are where the sort of discontinuities are going to occur on the tangent function. And so the tangent is undefined at pi over 2 and at 3 pi over 2. So that's kind of interesting, but also useful for this graph. The other thing that I'm going to say is that on a rational function, the numerator determines the x-intercepts. And so wherever the numerator is equal to 0, the sign, that's where the graph is going to cross the x-axis. And so that's happening at 0 and pi and 2 pi and so on. All right, and so we can kind of use those pieces of information to take a sketch of the tangent function. So I'm going to make a graph that goes by pi over 2's. All right, and then I'm going to say, well, we know we have vertical asymptotes at pi over 2, and we know we have one at 3 pi over 2. Tangent is periodic because sine is periodic and because cosine is periodic. And so we can kind of make some predictions that this will continue along. And then the other thing that we know is that we have x-intercepts at 0 and pi and 2 pi. For right now, I'm going to gloss over some of the really important details about tangent, but of course you could find some additional points to figure out, exactly how these spots show up. But the sketch of the graph will always look like this, basically. I'm going to accept not a whole lot of specificity with these tangent graphs because, first of all, I'm not here, and second of all, we don't really need to. So here's what the graph will look like. Like that, okay? And it's just going to kind of continue along this shape. It's really nice looking. And there we go. So that's our parent tangent function. I'm going to label this as y equals tangent of x. So what we just kind of discovered is two things. The first thing we discovered is that the tangent function is periodic. And we also figured out the deal with the asymptotes. We'll talk about that a little bit more. But for your reference right now, we're not going to call it an amplitude for a tangent function because there isn't a middle to top of graph. But instead, there's just a vertical scale factor. So that a is a vertical scale factor. And then the omega is still relevant to the period of the graph, but instead of it being pi over omega, it's 2 pi over omega, it's just pi over omega. So this is the new formula for period for just tangent. So that's what I'm writing there. And you can kind of look back at the previous slide and see how that would make sense, right? Like you can think, okay, well, it has those asymptotes. There's two asymptotes, in the space that there normally would be one cycle. Okay, and so obviously, like dealing with doing the asymptotes and everything for tangent functions is a little tricky, and so we'll deal with that as we go through these problems. So first thing to notice that is that our amplitude, our vertical scale factor is -2, which means that instead of this graph kind of looking like this, it will look instead like this, if that makes sense. It's going to flip upside down. It's just going to be steeper too. And then the other thing is that the period will be pi over pi, which is just 1. And so every 1 unit, this graph will repeat. So I'm going to draw a steeper version of our tangent function based on what we did in class just a minute ago. So here's our steep tangent function. This is not going to be perfect. That's okay. It's going to look like that. And then what we know is that we have asymptotes here and here and here. The repetition occurs right here and right here. And so this is at 1, and then this is 2. I'm not going to label my y-axis because there isn't really a good way to do so. The other thing that I'll say is that the asymptotes are happening halfway between 1 and 2 and between 0 and 1. And so this is at 1/2 and this is at 3/2. It doesn't look like that, but it is supposed to look like that. So what I just kind of learned is that without any horizontal translations and all that stuff, the asymptotes are happening sort of halfway through each period. So you can think about that from that perspective. We can take our period and then divide by 2, and then we add every period, multiples of that period. And so we would write k times 1 for k in the counting numbers, which is the natural numbers, and the ends. Anyway, this is really beyond the scope of what I need you to know right now, but the asymptotes are occurring at these. X equals these. We'll do more with that on Friday. I don't need you to know everything about that, but I am going to show it for the next one as well. I did make one mistake here, and that's that all of these graphs are supposed to be upside down, so I'm going to fix that right now. Should look like this, sorry. And so this spot is 1, and that spot is 2. It should have crossed right like that, I'm sorry. There, that's much better. All right, the next one is tangent of 1/2 x. The period is pi over 1/2, and so that would be 2 pi. And then our amplitude, or our vertical scale factor, is just 1, and so we'll have our default sketch. That. Okay, draw our asymptotes through here, like that, like that. Every time it repeats is a 2 pi, so that would be 4 pi. And then this would be at pi, and then this would be at 3 pi. That, I think, is enough information for you to go off of for your worksheet. Let's just talk really quickly about the asymptotes. So we take our first asymptote, which is at x equals pi, and then we're adding multiples of the period. So 2 pi k for k in the counting numbers, which is the natural numbers. I suppose that's wrong. I suppose it should be the integers. So we use a double struct z for that. That should be here as well. Again, this part right here that I'm highlighting is not critical for you to understand today. It is important for you to understand where the asymptotes are coming from and how to plot them, but writing a formula for where they're happening is going to happen on Friday. No, I take that back, on Wednesday. Okay, this worksheet, the worksheet has some sine and cosine, but it also has some tangent. So work through that, and then I will see you all on Thursday. Have a good day. Bye.